Alright, lesson 11.3, we get into the actual algebraic percentages, so to speak, of this particular section. So we're going to be finding percentages. But one of the things that we're going to do, and in some of these cases you can reason yourself out with the realization that if we can figure out what is the part and what is the whole, we might be able to do some percentages in that particular case. One of the things I want to express to you today, though, is in many cases we can convert what's given to a simple equation. And once we do that, we can solve the equation. It's a matter of translating from, English into our mathematical sentences. So if you look at what I have here, what percent of 144 is 64? One of the things as I look at this, I can realize that, okay, we got of is multiply. Well, what percent? That's an unknown, so you know what? I'm just going to convert that. I'll use P for percent. 144 is our number. Is means equals. And then I have 64. And you'll notice in this particular case, I now have a simple equation. Well, if I realize that that simple equation can be solved by undoing multiplication with division, so if I divide both sides of this equation by 144, and this is where your part-whole thing comes in. 64 ends up being your part, 144 ends up being your whole. Our 144 is cross-reduced out of this multiplication. And so P, the percentage, is 64 divided by 144. And I'm going to just punch that into a calculator just to speed things up. And this ends up being 0.4 repeating in this particular case. Now we have to be careful here. This says what percent, so multiply by my 100. So move my decimal 2 places to the right. So my percentage in this case is 44.4, and that 0.4 will repeat. So 64 is approximately 44% of 144. So you can do it both ways. If you can figure out your part and your whole relationship, you can do your division that way. I like equations because I can solve equations relatively quickly. So again, if you want to do your part-whole thing, you can. In this particular case, I'm going to go to the equation again. Of means multiply, is means equals. And so those two things translate very quickly into algebra or mathematical symbols. What percent again? So I'll use P again for percent. Now if you want to further simplify this side into 92P, you can if you prefer to get rid of that multiplication sign. But realize that it is multiply going on between those two things. And we undo multiplication with division. So I'm going to divide both sides of my equation by 92. So my part in this particular case is 66. Divided by 92, again, I'm just punching it into a calculator. We have 0.71, 7, and I'm rounding. In this case, I'll go to the nearest, I'll go one more decimal place, which would round to 0.4. Now, this is not my answer yet, because it says what percent. So when I multiply by my 100 and I move my decimal 2 places to the right, that's the quick way. That equals 71. I will go 0.7%. I'll just round it off in this particular case to the nearest tenth. All right. What percent of? Okay, again, there's our multiplication. There's our equals. 240, 180. And again, I'll use P, which you don't have to use P. You want to, you can, if I want to simplify this, is 240p. You don't have to use p, though. You can use x, you can use y, you can use, well, anything. And I undo this multiplication by dividing both sides by 240. 240 over here, and these will reduce themselves out. And so 180 divided by 240 is 0.75. Oh gosh, I should know that off the top of my head. Decimal 2 places to the right, 75%. There we go. Alright, so let's do a little bit of a word problem here. Mount Churchill in Alaska is about 15,635 feet high. The height of Mount McKinley is approximately 130% of the height of Mount Churchill. To the nearest foot, find the height of Mount McKinley. Now, one of the things usually in most of these sentences or story problems is you have a key phrase. Okay, it's actually the phrase that tells you what to do. All right, and in this particular case, let me go highlight it, and I've paraphrased it here. But it's this part right here. Mount McKinley, the height of Mount McKinley is approximately 130% of Mount Churchill. That phrase there tells me what to do if I recognize the mathematical meanings of the words. All right, so first of all, Mount McKinley is, well, is, there's equal to 130%. Well, as a decimal, we'll want to translate that. Of is multiply. Now, the height of Mount Churchill, well, we know in this particular case that Mount Churchill in Alaska is about it's about 16,000 feet. We'll call it, we'll go with it's 15,635 feet. Okay? And Mount McKinley, that's the thing that we're trying to find. So if I just use M for the height of Mount McKinley, it's telling this key phrase is telling me that Mount McKinley is equal to 1.3 times 15,635. And in this particular case, I don't have to solve an equation because I have my numbers on the right side of the equal sign in this case, and it's telling me just multiply them together and you're done. So 15,635 times 1.3, our 130%, is 20,000. Oops, sorry, 20,000. Got to write a little neater than that. So 20,000. 320, and in this case it says to the nearest foot, which is going to, based on what my calculator says, I got a 0.5, which is going to round a 5 up to a 6. So in this particular case, Mount McKinley's height is 20,326 feet. But if I find the key phrase in the problem, it'll tell me basically what to do if I translate it into mathematical phrases. So, finding percents. A brother and 3 sisters built a treehouse in their backyard. Mary did 1/4 of the work. Josh did 0.28 or 28/100ths of the work. Carolyn did 30% of the work, and Laura did the rest. What percent of the work of the treehouse did Laura do? So we have these 4 siblings, and they build a treehouse. And the one thing that I know at this particular point is if I add all 4 of their parts of work together, that equals 100. 100% anyway. So Mary did 1/4 of the work. Now that's as a fraction. I'll leave it there. So Mary's portion plus Josh's portion, which is 0.28. Okay, great. Plus, let's see, the next one is Caroline. Caroline did 30% of the work. We don't know what Laura did. I'm going to use L for Laura. But we know the total is 100%. All right. So now, since this is in percentage format, although you could do it as a decimal or some other thing, 1/4 I know is 25%. So I'm going to go ahead and use that. 0.28 is 28%. And 30% here for Laura. Or no, not Laura, that's Caroline's. Come on, right, there we go. Plus Laura's. That total is 100%. Now you have choices of how you choose to do this. I'm going to go ahead and I'm going to add these 3 percentages together to figure out how much the 3 siblings did together. So 5 plus 8 is 13 plus 0, so 13, carry my 1, 3, 5, 8. So the 3 siblings minus Laura, their total, they worked or did 83% of the project between the 3 of them. So now if I subtract 83 out of 100%, which since I have set this up as an equation, oops, sorry, 83%, it looks like, 17% if I do the subtraction. So Laura did 17% of the work, because again, we know the total has to be 100, so if I figure out they add them all up to 100, we can figure out the missing piece. All right, so your turn to do some practice. Come see me when you need help. Good luck.